Good morning, good afternoon, good evening, everyone. In this video, I will show you how to draw the velocity of a particle that is along a path. So there will be a lot of axes there. So I draw them big so you can see everything. Let's say it's our axis X and Y. Okay. And this is the path of my particle. So my particle is starting there and going like this. Okay. And keep going this way. Okay. This is the path of the particle. How do we draw the different axes? So first we need to know at which points we are looking about the velocity. Let's say we look at this point there. This is my particle at this instant. The velocity, so it's going to the left. So the velocity is always tangent to the path. Okay, this is my v velocity. What does that mean? That means that this is my axis t, tangent to the path, and this is my axis n, perpendicular to the t-axis and toward the center of the curvature. Okay, so now my curvature is in that direction, so we go inside the curvature circle. So this is for n and t. Now for my axis r and theta, let me make them in green. So what you need to do is to draw your axis from xy, and best it will be to take the ups. So this is my axis r from 0, 0. Here we go, this one. So that will be, r will be this one. Let me make it a little bit bigger so we can see it. R axis, and the theta axis is always perpendicular to r. And it's going in the positive direction, meaning from r to theta, you have a plus 90-degree angle. Okay, so plus 90-degree angle in that direction. Okay, let me draw this axis a little bit longer so we can draw the velocity complement. Oops. Oops. Why I can't? Oh my God, it's grabbing the. Okay, you see what I mean? I want to do that. I will do it by hand. This axis. This way. This way. So where will be VR and V theta? I will make them in, let's say, red. Okay. I need to find the complement on theta and the complement on R for the velocity. So that will be VR, and that will be V theta. Okay. Last thing that you may want to find is your axis X and Y. So for axis X and Y, you need to draw your horizontal and vertical line going through the particle. Here we go. And here we go. Oh, this one is not super nice. Let me try to build it more. I'm doing without the ruler. It's easier, but it's faster, not easier. Let me try with this ruler. Okay, it's supposed to be 90-degree. I don't know why it doesn't stick well. Okay, that's okay. Here we go. So my V-axis, let me draw them in purple. My V-axis will be there. That will be my V-axis. And this one there will be the Vy. Okay? So something that you have to remember is we always have Vx square plus Vy square, and I take the square roots, that is equal to the magnitude of V. You always have also V theta square plus Vr square, that will equal to the magnitude of V. And your V tangent is always your V, because V is always tangent to the path. Okay. If you want to, if you have your V theta and you want to find Vx and Vy, V theta will have two complements, and same thing for Vr. Okay. I will say the easiest things to start with. Let's say we are at this point there. What is the easiest things is to draw the velocity V, because always tangent to the path. That will be tangent to the path, tangent to the path, etc. Based on which information you have, sometimes it's easier to find v, sometimes it's easier to find v theta and vr if you have the function r of theta, or r of t and theta of t. It depends what you have. But don't forget that your vector v and your vector v is the same for vr, v theta, so vx and vy. So if you add vx as a vector plus vy as a vector, you got v. If you add v theta as a vector plus vr as a vector, you get v. Okay, so everything needs to be coherent and the same. So I hope it helps you to draw your velocity in on different referential. Let me know if you have more questions.